Alrighty guys, welcome back to your remote learning experience. This lesson is going to be for Thursday, April 23rd. I hope you guys had a great Wednesday yesterday. Hopefully you were able to watch that video about some of the vocabulary that was on your sheet initially. I hope that gave you guys some clarity as to kind of what we're doing and kind of where we're going to be going, okay? So today's video is going to be diving a little bit deeper into some of that vocabulary, and this is actually going to prepare us. Hang on, I have a typo. Not very good at grammar, as you can see. This is going to prepare us for when we get into Punnett squares, or being able to predict certain characteristics for offspring when we know the parents' genetics and everything, okay? So today we are going to be working on a worksheet that kind of goes over genotypes and phenotypes, okay? So this is the worksheet that you guys are going to be doing, okay? And so I'm just going to go over an example with everybody today, and then I'll let you guys do the rest on your own, okay? There's 4 altogether, but I'm going to do the first one with you, so that way you can do the remaining 3 on your own, okay? So I'm going to go over the instructions very quick, and then we'll get right into it. So it says, over the past week, we have been learning about different concepts in genetics. Today, we are going to be focusing on genotypes and phenotypes. A genotype contains an individual's genetic makeup and is usually a combination of 2 alleles, okay? Remember, an allele is a version of a gene. A phenotype is a physical expression of a genotype. For this practice sheet, you will be watching today's video lesson, which is you should be doing right now, and then identifying the appropriate genotypes and phenotypes for specific traits. This will help us transition into working with Punnett squares. An example from the video has been provided below. Okay, so this is what we're going to be doing today. All right, so looking at this sheet, for all of the kind of practice problems, I guess, or scenarios I'm going to give you, I'm going to give you 3 different pieces of information, and using those pieces of information, you're going to fill out this chart. Okay, so the first piece of information that you get is hair color. Okay, so actually I want to be able to annotate at some point. Or sorry, not hair color, duh. The first piece of information that you're going to get is of a specific type of gene. Okay, and that gene is going to code for a specific trait like hair color. Okay, so that's going to be piece of information number 1. Okay. The next 2 pieces of information that you're going to get are going to be the 2 different alleles for that gene. Okay, so if you remember, an allele is just a version of a gene. So a gene tends to be more broad, so here we're talking about hair color, and the alleles for this gene are brown hair and blonde hair. Okay, these are just made up examples, so I'm not sure if this is actually how hair inheritance works in real life, but I just wanted to give you guys a few examples. Okay? I'm also going to tell you whether the allele is dominant or recessive, okay? Again, don't know if brown hair is dominant or blonde hair is recessive. This is just a made-up example, okay? So I'm going to tell you what the dominant allele is, okay? Remember, the dominant allele will take over the recessive allele if they're paired together, okay? So in this case, I've made the dominant allele brown hair, and I'm going to abbreviate or kind of represent brown hair with a capital H. Okay, so that is going to how I'm going to know that this is a dominant allele for brown hair. All right, and the recessive allele here is blonde hair, and I'm abbreviating that with a lowercase h. Okay, so if I see a lowercase h, that means I have an allele for blonde hair. Okay, so this information is important for you guys to fill out this chart. Okay, so I did the first one for you, and then I'm going to do the next 2 together with you. Okay, so in these columns right here, we have genotype and phenotype. Okay, so the genotype, I'm asking you for the combination of alleles. And for the phenotype, I'm asking you for the physical trait. which is a phenotype is a physical expression of a genotype. Okay? And then these are terms that we've also been using before, okay, or that you were introduced to on Monday, okay? So remember, this term homozygous means that you have two of the same allele, okay? So I'm going to write that off to the side, just in case you forgot. Homozygous is two of the same allele. All right, so if I say this word homozygous right here, that means I have two of the same allele. And then I also see recessive, okay? So that means that I'm going to have two recessive alleles, okay? Because I'm homozygous, I have two of the same alleles, and those alleles are going to be recessive. So the genotype for a homozygous recessive individual would be lowercase h, just like that, okay? And because I have two lowercase h's, that means that this individual is going to have blonde hair. Okay, remember the recessive allele can only be expressed, or the recessive trait, I guess, can only be expressed if we have two recessive alleles paired together. Otherwise, the dominant allele is just going to take over. Okay, so let's take a look at this next one. So this next one, I'm looking for the genotype and phenotype of a homozygous dominant individual, okay? So if I look at homozygous, I know that a homozygous individual has two of the same allele, okay? And then I see this word dominant, okay? So all that means is that this individual has two copies of the dominant allele. So that would be capital H, okay? And so if I have two capital H's, the only possibility here for a phenotype or a physical trait is brown hair. So I'm going to write that right here. Okay, so let's move on to the very last one, which is heterozygous. Okay, so heterozygous is two different alleles. Whoa. Clearly, I don't know how to spell. Heterozygous is two different alleles. So in this case, I'm not going to put heterozygous dominant or heterozygous recessive because it's implied that I already have one of each. Okay, so I'm going to even write down here one of each allele. Okay, that means that the genotype of someone who is heterozygous, when we're talking about the gene for hair color, they are going to have a capital H and a lowercase h. Okay? And since we have a capital H and a lowercase h, the presence of the dominant allele is going to take over the recessive allele. So that means the dominant trait is going to be expressed, and the dominant trait is brown hair. Okay, so this is kind of what the first chart would look like, all right? Just making sure that you put the genotypes where they belong in the chart and also the phenotypes, okay? So this is a good way for you guys to get some practice because eventually we're going to be working on some Punnett squares, maybe sooner than you think, and that process is important for us to know genotypes and also phenotypes, okay? Because if we know the genotypes of the parents, we can actually predict the probability of certain phenotypes or physical characteristics in the offspring, okay? So I'm actually very excited because we are going to be doing an activity pretty soon where you guys are going to be working with Punnett squares and certain traits that are actually part of physical traits that you can actually find on yourself. So I'm very excited for that activity. Hopefully we get to do that at the end of the week. Okay, so just take a look at the rest of this sheet that I'm going to be posting on PowerSchool Learning, and let's see, let's try to get it in by Thursday afternoon. Tomorrow's Thursday. Maybe Friday afternoon would be a good time to hand this in, okay? So that gives you plenty of time to work on this and also ask questions if you have any, okay? So that is going to be it for today's lesson. So feel free to ask me any questions if you get confused on the rest of these problems. But other than that, I hope you guys have a great rest of your day, and remember to stay healthy and safe.